compute the line integral where f is given by this vector and c is the line segment from 100 to 412. First we need to find the parametrization of this line segment. Okay, so this is the initial point and this is the final point, so we know that this will be just vector x in terms of t, y in terms of t, x in terms of t, y, and gt is equal to, first let's make it vector 100 times 1 minus t, initial point times 1 minus t, plus final point 412, okay, 412 times t. So basically we need to multiply inside, same thing here. Okay, so 1 times 1 minus t is just 1 minus t, 0 times just 0, 0 times 0, plus here 4t, 1t, 2t. If we add 1 minus t plus 4t, so 1 plus 3t, 0 plus t plus t, 0 plus 2t, 2t. So the parametrization for this curve C is, then r of t is in fact 1 plus 3t, t, 2t. Later we need to evaluate this, as we know f dot dr is the work done by this force in this force field. This is same as t from a to b, f in terms of t, rt dot r prime t dt. So we need r prime. So as soon as I have this r, that's the path, which is line segment here, let me find r prime t, a derivative of first component, second, third. 1 plus 3t just 3, 0 plus 3, derivative of t is 1, derivative of 2t is 2. Okay, that part is done. And when we write this type of parametrization, remember we are assuming t is from 0 to 1. Okay, when t equals 0 we get the first point, when t equals 1 we get the second point. Okay, let me write down here 0 t 1. Okay, now we need to write this f function z square x square y square in terms of rt, because we need f of rt, and where r is 1 plus 3t, t, 2t. So pretty much we plug this rt into this function f. Okay, this is like x, y, and z. Okay, now f function in terms of r is equal to, if we go up, that's z square x square y square. So z square means third component. Here basically we can think x, y, z. So z square means 2t squared, 4t squared. Then x square means 1 plus 3t squared, quantity squared, comma y square means t squared. Next, to evaluate this line integral, we need to find the dot product of this r prime t with this. Okay, so f of rt dot r prime t, so the dot product of these two vectors. So we just find the sum of the product of corresponding components. So 3 times 4t squared, 3 times 4 12t squared, plus 1 times 1 plus 3t squared, just 1 plus 3t quantity squared, plus 2 times t squared, 2t squared. Let's simplify this. This is 12t squared. We need to FOIL, multiply 1 plus 3t by itself, 1 plus 6t plus 9t squared plus 2t squared, 12 plus 9, 21 plus 2, 23t squared, plus 60 plus 1. Okay, thus the line integral we are asking for dr, this is same as the parameterization, and that is always from 0 to 1 the way we did. So 0 to 1, and this dot product we found here, 23t squared plus 6t plus 1 with respect to t. Now back to calculus 1, easy. Antiderivative of first 23 t3 over 3, I can write here by the way, plus 6 times t square over 2 plus t, and we need to evaluate from 0 to 1. So the upper limit, just plug in 1 for t. So 23 thirds, 1 cube is 1, plus this is 3 times 1 square is 3 plus 1 minus lower limit t equals 0 makes 0 0 0, so there is no contribution from the lower limit. And if we add, that's the 3 is the common denominator, 3 times 3 9 plus 3 times 1 3, 9 plus 3 12 plus 23, that's 35. Okay, final